Hello and what's up? ESP8266 season, isn't it? In my previous video, I've shown you these modules. These are pretty nice and little modules which you can use in your IoT platforms and also control your projects using Wi-Fi, using your smartphone. And also made this little contraption to use it with your breadboard because the pins are not breadboard friendly. There we go. Nice little. Go check that out, my previous video where I built this contraption to use it with my breadboard. This is the breadboard adapter for my ESP01 module. It's pretty cool. It serves its purpose. So in this video I will show you some basics about these modules, and mainly I will show you how to upgrade the 80 firmware. I will talk about in a minute what is the 80 firmware using your Arduino Nano. You can program these, as I've told in my previous video, that these are actually, you can use these as your standalone microcontrollers. You don't need Arduino to use these because it's nice little microcontroller we can use, which also features Wi-Fi. So basically I will show you how to upgrade this firmware using your Arduino Nano. You don't need those USB to serial or TTL converters. If you own an Arduino, Uno or Nano, anything will work. Don't know about the Mega though, but if you own anything Uno or Nano, you can program these using those Arduino boards. So without wasting time, let's get started. So see, for a beginner, as I also never touched these modules before, I suffered some little challenges and also suffered from little difficulties. So basically this is the pin diagram of these modules. As you can see, the important pins why you will be using these with your Arduino are those RX and TX pins and the enable and the VCC pin, and obviously the ground pin. So basically what we are left with are those two GPIO pins, GPIO 0 and GPIO 1. So I will leave those pins for today. Also we will need that GPIO 0 pin for flashing this thing, but I will talk about it in a minute. Basically what you have to do, what you have to remember first of all is this thing cannot be operated in 5 volts. This actually needs 3.3 volts input, and that 3.3 volt inputs is also should be kind of beefed up. By beefed up what I mean is you cannot use your Arduino's 3.3 volts power pin because these things are power hungry. These things need some decent amount of juice from your power supply. So your Arduino's power supply cannot supply that much amount of power. I also tried the same using my Arduino's 3.3 volt power port to power this thing, and it pretty much failed, as you can see in this video. What the f? Something sorted or what? Let me see how much current it's drawing. Piece of shit. 80 milliamps? Are you kidding me? And later I found on internet that this thing actually needs around 150 milliamps to actually function correctly, or what I remember. I will leave that in here. This is the amount of current it needs to operate. It's kind of big for your Arduino to supply. So you have to use the external power source to power this thing up. And also if you are using with your Arduino, you will also have to short the two grounds of your two separate power supplies, because otherwise it may suffer from some errors, isn't it? So I used my 12 volt lithium ion battery pack and stepped it down using my buck converter to exactly 3.3 volts, and now it works, as you can see. Now let's talk about this RX and TX pins. If you want to access these modules with your Arduino board, basically what you have to do is to convert your Arduino into a USB to TTL converter is basically short circuit the Arduino's reset pin with the ground. That's the basic thing you have to do to communicate with this thing. And also remember, while communicating with this thing directly, you have to connect RX and TX pins to exactly the RX and TX pins of your Arduino. What I mean is you have to connect the RX pin of your Arduino to the RX pin to this ESP01, and you have to connect the TX pin of your Arduino to the TX pin of this thing, not the opposite, okay? Because you are not using your Arduino still. You're just communicating with this thing, not your Arduino anymore, because you have resetted your Arduino using that little contraption, short circuit between the reset and the ground. So your Arduino doesn't recognize it as an Arduino. It just performs a USB to serial converter thingy. Okay, now as you can see, after powering this thing up, you have one line of garbage values in your serial monitor and then a ready message. So basically, if you don't receive this, then you may have connected your RX and TX pin in the wrong order, or you have not set the correct baud rate for your serial monitor. You have to select 115200 baud rate, because that is the specific communication speed this thing works. And also you have to select both NL and CR. If you do everything correctly, you have to receive those two lines, and by a set of commands these things are controlled, which are called AT commands. You can type AT in your serial monitor to receive OK. If when you type AT, it will reply you with OK. That means everything is fine. So that's how you have to communicate with your thingy. That's the basic we have done. I will discuss about these AT commands in another video. Obviously, you can do everything, connecting to your Wi-Fi or creating a new access point or your smartphone to be connected to that particular access point. You can do everything with this using those AT commands, and that's where we want the AT firmware, isn't it? You may have received a ESP module which doesn't have an AT firmware, so you cannot receive any of those AT. It will not respond to any of your AT commands. But basically, generally what you receive, because these things are made in China and these are also cheap, so you don't have the specific version of these. As you can see, there is no company written in here, just in the back ESP01 is written, so you cannot identify the actual ESP8266 modules which are genuine and which are not. So basically, this thing, the AT firmware differs from model to model, as mine has received an AT firmware where I cannot do anything with it because the AT firmwares are pretty much outdated. I mean, pretty much outdated. I have upgraded it twice or thrice now, and now it works like a charm. Now to flash this thing, you just have to need the same configuration as you have communicated with this thing. You have to connect the GPIO 0 pin to the ground, and that is the flashing mode. And when you connect the flashing mode, when you connect the GPIO 0 to your ground and then open the serial monitor of your Arduino to see what's inside it, then you will see only one single line of garbage value. It will not say ready anymore because it's not in working mode, but it is in flashing mode. You have to remember that. Now let's talk about some IoT platforms. I have tried one application called Remote XY, where you can create your access point and also a kind of web page in which you can actually communicate with your smartphone to send data and receive data. But that failed to work because of my AT firmware. So let's see how to upgrade this AT firmware. Step 1. You have to connect the GPIO 0 pin to the ground of your ESP01 modules. And also, if you are flashing using Arduino, which I am showing you, you just have to keep the same configuration as I have told previously, which is connect RX to RX, TX to TX, and also reset to ground of your Arduino. Well, because as I've already told, if you connect reset to ground, then Arduino actually performs like a serial USB to TTL converter or USB to serial converter. It doesn't works as an Arduino anymore.
So Blink is a very nice IoT platform, at least what I have researched in the internet, and actually it didn't work out for me, but for sure I will try that. It also needs a specific AT firmware. Basically all of these platforms need a good AT platform, and see, this is what I found out. In the Blink's website you can see these are the tested AT firmwares, and as you can see, the last one, that is AT version 1.1.0, which is released in May 11, 2016, it seems to work the best. As you can see, version 1.1.0, and it has a SDK version of 1.5.4. And I don't know what the heck is this BABBBBB or whatever the I don't know what this is. So this is what I have to install. But first of all, you have to check what firmware is in your ESP. To do that, you have to type a command called AT plus MGR. Sorry, GMR. As you can see, this firmware is actually kind of bad. As you can see, it resets continuously, and I suffered all these issues, and can tell you that these are common in ESP01 modules, and it resets rapidly. And that is not because of your power failure, as I have shown you that these modules are actually power hungry. So this is not because of the power hungriness. This may be because of the power hungriness, but if your power supply is alright, then it also happens because of the AT firmware. It depends on the firmware too. As you can see, mine resets rapidly as soon as I type GMR. But as you can see, I have stopped it manually and scrolled it, as you can and you can see the AT version is 0.5.0, which is released in September 18, 2015, as you can see, and also the SDK version is low. So actually mine is a downgraded version. So it's always the best option for you to upgrade the firmware, because everybody knows updated things are good, isn't it? And it's always a good choice to actually upgrade your AT firmware first in your ESP8266 modules before using them with your anything like your IoT platform or something like that. So basically what we have to do is upgrade this and that's the thing I'm gonna show you. And also you can see the second boot version. This is actually kind of needed for you. You need this information to actually download your AT firmware. As you can see, SPI speed, SPI mode, and SPI flash size. Basically SPI flash size is the main thing you need. As you can see, mine is 8 megabits of flash. You might have a 16 megabits of flash, and also you can see the map, that is 512 KB plus 512 KB. So this is the parameter you need, actually this is the information you need to download your AT firmwares, because there are all kind of firmwares available for every versions. This is the 8 Mbit version, there are 16 megabits version, also there are 32 megabits version. So you need this information for downloading your flash. So basically what we have to do now is to upgrade the firmware. So basically, as you can see, I have downloaded this thing, and as you can see, there are two versions. One is 8M and another is 32M. So as you have seen in my second boot version information, mine is 8 megabits of flash. So I will select the 8M version, and also you can read this readme file always. As you can see, this is flash size 8 megabits. So I will select that. So I created a new folder actually for firmware upgrade, because you download the binary file and the flasher separately. Okay, so I've just combined these binary files and the flasher in that folder, and you can find that folder in the description down below. You can download it and enjoy the fun, because it's very simple to flash. As you can see, this is the flasher. There is a binary file, location, position, and the COM port. You can find the COM port very simply by just looking at your Arduino COM ports. As you can see, mine is COM4, so I will just type COM4 in there, and then I will load the binary file which I have downloaded, which is of version 1.1.1.0 or whatever. So now what you have to do, just have to power up the ESP01 like before with your external power supply, because Arduino's power supply cannot supply that much amount of juice it needs. It's pretty power hungry, and this is the problem I faced couple of times. As you can see, failed to connect, and I suppose this is a connection issue with the serial ports. Like you are connecting with, I was connecting using jumper wires to my Arduino's RxTX pins and the ESP's RxTX pins. So there may be a possibility of loose connection, but I don't think so, because I have checked, double, triple, quadruple checked many times, but still it keeps on happening. The problem, however, solved for me is after I click the download button and then I power up the ESP. So there is a little message which is throws to the Arduino's receive pin, and that's why maybe it detects that the ESP is connected, so it doesn't fail to connect again. As you can see, I click on this download button and then I powered up the ESP, and as you can see it says erasing flash, and also there is a failure message for me for the first time. That is also maybe, I suppose, for the loose connection in the transmission line. That is, our RX and TX pins are not connected solidly to our ESP01. So basically that is the trick which worked for me, is first click on the download button and then power up the ESP01, and then leave everything as it is. Don't even touch the RX lines, because it may cause loose connection again and your writing will fail. And as you can see, it will take some time to write the flash. To actually download the firmware, it will take a little bit of time, maybe 2 to 3 minutes. Just be patient, and again, do not touch the RX lines, because it will pretty much the whole thing up. After the flashing is done, as you can see, there is another error message that it failed to leave the flash mode. But don't worry about that either, because it is pretty common in these modules. I also pretty much scared for the first time when it returned this message, but this is pretty common. You don't have to worry about it. You just power up the Arduino, just power off the ESP, because it is supplied from external power. Basically, after you do that, you have to disconnect the GPIO 0 from the ground. Don't forget to do that. And then again, you can open the Arduino's COM port, serial monitor, and then power up your thingy. And as you can see, there's a little bit of newer message, AI thinker technology. This was not before. And you can then type your 80 commands, 80 plus GMR again to see your version. And as you can see, it happened pretty nicely. It says the version and the SDK version which we are targeted to achieve. Let me open that for you. And there we go. As you can see, the 80 version and the SDK version is actually the same. So we successfully upgraded our ESP01 modules, and it also doesn't resets like before. As you can see, this is constant, doesn't resets anymore. So there we go. You see, I have resetted it now, and it resets one time. No loop reset. So we fixed that problem. As you can see, SPI speed flashes again. You just have to see that, you just have to type 80 plus RST. You just have to type that command to see your flash size. It's pretty cool. And for checking the version, you have to type 80 plus GMR. There we go. It's done again. And now we can use it in our IoT platforms, isn't it?
Hope you enjoyed this video. If you did, give it a thumbs up, thumbs down for the opposite, and if you haven't subscribed yet, don't forget to hit the subscribe button and click that notification bell icon to get notified about my latest uploads. You can also find my link up to my Patreon profile in my description down below. So if you want to support it, I highly appreciate it. So basically that's all for today. This is Mala, you are watching Arduino Syllabus, and for today I am signing off.